Now in this problem we've got a P is a point on the parabola for x squared equals 4ay, and the tangent at P meets the y-axis at R and S, and we want to prove that RS equals SP. So we've got our tangent at P, and we want to meet that RS is equal to SP. So let's have a look. We get our equation of our tangent because we know what the gradient of the tangent is t. We find our equation of our tangent, tx minus y minus at squared. So we've done it a few times now, so hopefully that's becoming pretty much second nature. And at R then, where it crosses the y-axis, we get x is equal to 0, so we sub it in. We get the point R being 0 minus at squared. So we know that A is the distance of is at 0a, so the distance there for RS would be a plus at squared, because it's at squared distance from the vertex to the R, and then from the vertex to the focus is a, so we just add the 2 there, so we get that value. So and then to find SR, so there's SR, and then to find SP, well, we know that's the square root of 2at minus 0 and at squared minus 8. So we've used the focus and the point P. So we expand it out. We collect our our terms there. So we get at squared plus 8, because we have a look, that works out to be a perfect square, because we get the a squared t power 4, 2a squared t squared, and a squared. So we get at squared plus a all squared. You could have factorized a out as well earlier on, but it doesn't really matter as long as you can get that perfect square and realize that, because that gets rid of the square root for us, and we get at squared plus a, which is a outside of t squared plus 1, so they're both equal. So that's how we do it. We've got to make sure we can do that manipulation with the algebra, so be able to come down. We know what we're looking for as well. We know what we're trying to get to that. So keep that in mind. We want our SR to be equal to SP. So you know what your manipulation needs to come down to. You know you have to get rid of the square root. How do you get rid of that square root there? Because there's no square root in this one. Then you need to have a perfect square. So you need to be able to get that down to some perfect squares and manipulate it so it will come out there, so the square root will cancel with the square. In question 5 here, we've got, again, 2 points on the parabola. X squared is equal to 4y. And first part is to show the equation of the chord PQ is that one. So again, you've done this a few times. And these are exam questions which will start with that. So they'll start and find the equation, the gradient of your tangent, your chord, and then put that into the equation of a straight line, and be able to get down to the question and get down to the answer we need. Then find the cornerstone, which is the midpoint. Well, finding the midpoint's not too bad. 2p plus 2q over 2 and p squared plus q squared over 2. And the 2's will cancel there. So there's our midpoint. Now, here is something we haven't done. The next thing we want to do is find the equation of the locus of M. So basically, as P and Q move, then the midpoint will also move. So as P and Q move around and you get different chords, M will move as well. Now, M will move according to this rule, because we'll always have the coordinates, and we'll have the coordinates where we have P plus Q for the X coordinate and P squared plus Q squared on 2. So it actually starts to move in a certain way. Now, what we need to do is get a relationship between X and Y, because we want to find the equation of the locus. So we need to manipulate that back from its parametric forms back to a Cartesian form. So what are we talking about there? So basically what we're saying is, if 0, 2 lies on PQ, then we know there's a relationship. We can sub 0 and 2 into the equation. So 0, 2 is always going to be on PQ, and PQ is going to move, but it'll always go through 0, 2. Now if that's the case, we get able to manipulate 2PQ down to minus 4 and PQ equals minus 2. Now that's important in what we need to do. And that's where that information was given, why that information was given to us. Now, from what we had, we know this is the X coordinate and this is the y coordinate. We need to get them related somehow. Well, they are related because they've both got p's and q's in there. So that's why we were able to write x is equal to p plus q and y is equal to p squared plus q squared over 2. Now what we want to do is get x in terms of x and y being related and get rid of the p's and q's. So if we remember our manipulations we've done before, p plus q all squared is p squared plus 2pq plus q squared, or p squared plus q squared could be written as p plus q all squared minus the 2pq. And that's what we're going to do. We have a half come out the front. We've got p squared plus q squared would be p plus q all squared minus 2pq. We've done that manipulation. Now, why have we done that manipulation? Well, it allows us to get this idea because p plus q is equal to x. So that's why we're able to do that swap in there. And from the previous part, we saw that p times q is equal to minus 2. So we're able to put that in. Now, we've got rid of p's and q's in there. And all we've got is y in terms of x, which means we can just clean it up to get y is equal to a half outside of x squared plus 4, which is a parabola. M's going to move such that it will be a parabola because it's y and it's equal to half x squared plus 2. So that's what we're going to get. So P and Q is going to, as P and Q moves, M moves, and also PQ also goes through the 0.02, but M's going to move, and it's going to move such that it's going to give us a parabola there. So there's our manipulation when we want to find the equation of the locus. We have to start to get P in x in terms of y, or y in terms of x, and get that relationship and get rid of the parametric unknowns. So the next question here, we've got the variable on the point x squared is equal to 2y. We're given x is equal to t. So what y in terms of t? So again, if x is equal to t, t squared is equal to 2y, or y would be equal to t squared on 2, or a half t squared. So that's a pretty easy manipulation to start off with. So write an expression for t for the square of the distance m from p to the point 0.06. So if that's our 2 points, the distance squared would be t minus 6 all squared plus t squared on 2 minus 0 all squared, which we can just expand out to get that. So that's all we wanted. Expression in terms of t for the square of the distance m. Now it then says, hence find the coordinates of p such as p is the closest to the point 0.60. So, well, if we're looking for the closest to the point, that's like finding a minimum. If we start talking about a minimum, we're finding the value of that. We're going to use calculus then and find the stationary point technically, and find where that is equal to 0. We start to manipulate. We get t is equal to 2 once we solve our cubic there, and then that will give us the point 2,2 because we find that t is equal to 2 there. So again, if you're looking to solve that one, you can use Newton's method, or you can use any other method you like. If you want to be able to break it down into some factors, you can use whichever form you like to get t is equal to 2. And so that means we get the point 2,2 because when t is equal to x is equal to t, we get t 2 squared, well, x is equal to 2, t is equal to 2 from that, and 2 squared on 2 would give us the other y coordinate of 2. Question 7, we've got a straight line meeting the parabola at those 2 points. So find the equation of the chord, and hence, or otherwise, show that you can write PQ equals minus B on A. So we solve that simultaneously. So x squared is equal to 4ay, and y is equal to mx plus b. So that's why we're able to do that substitution. X squared then would be equal to that form. We know from the PQ there, the gradient of the chord then would be P plus Q on 2. So we can find the equation there of that one as we've done before, like put 2AP in AP squared. There's our equation of our chord doing that. Now we know that we've got this relationship. We know we're getting this relationship now. We can manipulate it also to get it in that form. So y is equal to that. And so we also knew y is equal to mx plus b. Now if that's the case as well, we know that p plus q on 2 would be equal to the m, because that's in front of the x, and apq would be equal to the b. So if that's the case, minus APQ would be equal to B, or APQ would be equal to minus B, so PQ is equal to minus B on A. So we're able to manipulate all those around and to suit our purposes. Prove then that P squared plus Q squared is equal to M squared plus 2B on A. Now we just said that P plus Q there is equal to M, because we were able to equate our constants there. So P plus Q on 2 is equal to M, so P plus Q is equal to 2M. So P squared plus Q squared, we're able to remember we can write it P plus Q on 2, all squared minus 2PQ, which we can write as 4M squared plus 2B on A. So there's our manipulation that we can get, that for P squared plus Q squared, because we know P plus Q is equal to 2M, we can do that manipulation from PQ and P plus Q. So given that the equation of the normal of parabola is that one, so you don't have to prove it, you're given that. N is the point of intersection of the normals, and has that, express these coordinates in terms of AM and B. Now here's where we have to play around with our algebra. We've got minus A times PQ, P plus Q. Well, from what we just had in part 2, PQ can be written as minus B on A. P plus Q can be written as 2M, which we can cancel down with 2BM. So that's simplified. Now we got A outside of 2 plus P squared plus Q squared plus PQ. Now we just showed that P squared plus Q squared is the 4M squared plus 2B on A. So that's where we get 2, 4M squared plus 2B on A. And PQ is minus B on A, so we can substitute that in. We can clean that up because 2B on A minus 1B on A is 1B on A. And then we can cancel by the A there, or expand through by the A. So we get the 2A plus B, because that cancelled, and 4AM squared. So there's our X and values that we put in for X and Y coordinates. Now, given that, we're asked to suppose the coordinate is free to move, find the locus of N. So we just found what N was in terms of all the parametric forms, but now we want to find the locus of N, the equational locus. So we know that X is equal to 2BM, so B would be X on 2M. So that comes straight from there. X was equal to 2BM, and Y is equal to 2A plus B plus 4AM squared. So we need to do our manipulation there. So B is 2X on 2M. So we can write that. We get 2A plus 4AM squared. And that, remember, they're just constants now. So we've got X and Y, which gives us a straight line, 1 on 2M and 2A plus 4AM squared. That gives us a straight line there. So verify that this line is a normal to the parabola as well. Now we haven't got that there. We can do that manipulation when we get the P and Q, and we able to find that with that one there. So we get the minus 1 on T squared. So then question 8, we got, considering this parabola, X squared equals 12Y. Show that P is equal to P is 6P on in 3P squared, lies on the parabola. Sub it in. So you're just saying show that it lies on the parabola. Well, how do we do that? We just sub it in. So yep, it works out to be true. Subbed in X, found the Y coordinate, so it was true. Find the coordinates of midpoints joining that. So we 6P plus 6Q on 2. So that comes down to 3P plus 3Q. 3P squared plus 3Q squared. Well, that can't be simplified any further. Now, the chord has a gradient of 1. Prove that P plus Q is equal to 2. So we find our gradient there. Make it equal to 1 because that's what we're told to do. We can start cancelling. We get P plus Q on 2 is equal to 1, or P plus Q is equal to 2. So that's proved as well. And then, hence, find the equation of the locus of the midpoints of the chord with gradient 1. Now, if that's the case, we go back to what we had, then that was the gradient. That's where we got the coordinates of the midpoint. So X is equal to 3P plus 3Q, which we could write as 3 outside of P plus Q. But from part 3, we know P plus Q is equal to 2. Now if that's the case, then that gives us 3 times 2, and that means x is equal to 6. Well, what does that mean? What restriction is the locus there? Well, it doesn't matter what the y values are. We're always going to get a horizontal line, a vertical line, x is equal to 6. So that's the restriction there is on this locus. It's always going to be along a vertical line, x is equal to 6. So the locus is the midpoint of that chord. Okay, and that's only if it's going to take gradient of 1. So that's what's so special about that one. So there's some problems. We've introduced finding the locus in this case. Now sometimes it's going to be an easy manipulation, like we saw there. Sometimes it'll be a little bit harder manipulation. So again, it's about using your algebra skills to be able to do that manipulation. And as in next, we'll be checking this in class and doing a few more problems, and hopefully being able to get our head around doing a few harder problems involving this type of algebra.